And welcome back. Here we go. Section 3.8, derivative of an inverse function, and actually derivative of inverse trig functions. This first part we're just going to deal with the derivative of the inverse function. And we have to first remind ourselves what an inverse function is. Okay? An inverse function, okay, is where in Algebra 2 they told you to take the x's and take the y's and flop them and then swap for and solve for y. Okay? So over here I've got my normal little equation, y equals 3x plus 4, and I'm going to make the inverse equation. Okay, so to do the inverse equation, swap x and y, and now solve for y. Subtract the 4 from both sides, divide by 3, and that now equals this y. But again, we want to denote that the y that's over here is different from the y that's over here, and that they do have a relationship to each other. And so we often say that this is a function with respect to x, and then our inverse function can be denoted as f inverse of x. Okay? Again, these are things you should know from Algebra 2. And so we want to actually go a little bit further, and one of the things that you should have picked up last year in pre-cal is an even deeper relationship between f of x and f inverse of x. So the deeper relationship you should do, or should see, is by figuring out what f of f inverse of x is. And look at that composite function. So again, the way that works is I start off with f, right? Say it's 3 times x. Well, what's x? X is really f inverse of x. F inverse of x is this crazy business right over here. So x minus 4 over 3 plus 4. And I can go ahead and simplify. And upon simplifying, what I find out here is that my 3's can cancel. I get x minus 4 plus a 4. And my 4's can cancel, and I get just plain old x. And that's the relationship I want to take a look at. The relationship that I want to take a look at is that no matter if I'm giving a function and an inverse function, if I find out what f of inverse of x is, it will always give me x every single time. That's an important fact. How important? I gave it its own slide. Okay? And it's super important. This is important. You may want to know this. The reason why you want to know this is because this is how I remember what the derivative of an inverse function is. Because again, there's another relationship between f and f inverse for f inverse's derivative. Okay? Whew, that's a lot. F inverse derivative. I want to search that out. Okay? So if I want to find the derivative of f inverse, let's start by what happens if I take the derivative of this now composite function that I have, this relationship between f and f inverse. And if I take a look at this and I take the derivative, well, it's a chain rule, right? F is my chocolate shell, f inverse is my chocolate. All right, so I take the derivative of the shell, so f becomes f prime, leave my chocolate alone, times the derivative of my chocolate. The derivative of f inverse, well, shoot, I'll denote that as f inverse prime of x. Oh, okay, f inverse prime of x, okay, equals x derivative of x, 1. The reason why I was pausing is because, look, I want to know this. I want to know what the derivative of the inverse function is and what's the relationship. Oh, so why don't we solve for it? Why don't we just divide both sides by f prime of f inverse of x? And when I do that, of course, that all cancels out and goes away. And what I'm left with is the derivative of f inverse of x is equal to 1 over f prime of f inverse of x. So you have two things to think about here. You can choose to memorize this rule. Okay? Or you can choose to memorize this fact. Now, mind you, okay, just memorizing the rule is easy. Okay? Not easy, but it's the easier path. You don't have to take the derivative each time. My thing is when I try to figure this out and I try and figure out what is f prime of f inverse, maybe it's f inverse of f prime, I can never remember, which is why I set this relationship, I memorize this relationship here and just take the derivative each time. Mainly because you're only going to be asked to do this maybe once or twice on the AP exam. All right? So, your choice. You can choose to memorize this and take the derivative, or you can choose to memorize the actual derivative. So how is it used? Okay, great, glad that you asked. So here's a quick example. Given that f of 3 is equal to 9 and f prime of 3 is equal to 4, find f inverse, well, instead of putting the prime there, I'm going to put the prime out here. F inverse prime of 9. Okay? Well, again, I have that relationship that I just figured out, right? So f inverse prime of 9 is equal to 1 over f prime of f inverse of 9. Oh, that seems easy enough. F inverse of 9. Okay, great. Hey, they don't give me f inverse of 9. Huh. But what they do tell me, okay, well, let's see what they do give me. They give me this. They give me that. And so what does that mean? Huh. Well, remember, this is like my x, and this is my y. Oh, but don't you remember when we do the inverse, the x's and y's switch? So really what this means is f inverse of 9 is equal to 3. They switch. So now when I do f inverse of 9, oh, well, that's just really equal to 1 over f prime of 3. And what's f prime of 3? F prime of 3 is 4, is equal to 1 over 4. And that's the example. Okay? And that's what you're going to have to do, okay, for your homework based on this section. It's right here. Okay, D cubed worksheet. Okay, we haven't gone there in a while, right? Part 5, 54 through 62. Okay, that's the end of this section. Please leave any comments or questions that you may have. I'll take a look at those. All right, you guys have a good evening. We'll talk to you tomorrow.